couple of problem types are going to be dealing with number 25 and number 27 from your homework. Okay? So they are converting repeated decimals into fraction form. Okay? And you go about doing that by setting up an infinite geometric sequence. Okay? So the decimal 0.55555555555 foot long, okay, goes on forever and ever and ever. And the repeated value is 5. So the first thing that you're going to do is you are going to set up an infinite geometric series. Okay? So, if I set up this infinite geometric series, that's like saying 0.5 plus 0.05 plus 0.005 plus 0.0005, right? And so on and so forth. If I add all those together, okay, that gives me 0.5 repeated. Okay? Right? Okay. So, from that now, let's set up an infinite geometric series. Okay. So, what's my G sub 1? Right? Okay. What's my R value? Find an R value.
Take the term and divide it by the last term before it.
Term right before it. So any term divided by a term right before it. 0.1. 0.1? Okay. Okay. So, when I'm setting up an infinite geometric series, how am I setting it up? What form am I going to set it up in? Or what notation? Matt?
G sub n equals 1 times r times n.
But what's n? David? It's infinity, right? Okay. So if I'm asking you to set up an infinite series, what kind of notation do I want it in? Sigma. Sigma notation. Because that brings in the series. Matt, you gave me just the rule, right? I need to bring in, if I'm setting up the series, that means I need to have a sum sigma notation. Okay? How do we set up a sigma? What's the first thing we got to pick? First thing you got to pick in sigma notation. You got 26 choices. You got to pick a letter. Okay? What letter you want to go with? N? Okay. n going to start at? 1? Okay, that's fine. Where's n going to end at?
Infinity.
Infinity.
Goes on the top.
Yeah. Now we put the rule. So what's the rule going to be? .5 times 0.1 to the what? To the n minus 1 power. Okay. So we set up our series. Right? Now, my question is that R value within my range from yesterday?
Yes.
Yeah? Okay, that R value is within the range. It's within that -1 to +1 range. So I can find that sum. Right? Okay. So step 2 then is going to be find the sum. What do I need? Already got them, right?
Yeah.
Right? I found them when I was setting up my rule. Okay? So the sum is going to be what? So what is that? 0.5. Right? So that's going to be what? 0.5 over 0.9. Now we come to a crossroads. Because what do you want to do?
Divide it.
On what?
Your calculator.
On your calculator. You want to divide it on your calculator. If you divide it on your calculator, what are you going to get? No. What are you going to get? Do it. Do it on your calculator. What do you get? 0.5 divided by 0.9. What's your decimal? What you started with, right? Okay. What you started with. But what do we want our answer to be in? We want it to be in a fraction. Okay? So, using your calculator is not going to do you any good because your calculator is going to give you back the decimal.
What if we use the graphing calculator?
Still going to give you back the decimal because you've got it in decimal form. Okay? So you got to use some logic here now. I want a fraction. Okay, that would be one way of doing it. We could do this as 1/2 divided by 9/10. Okay, then what do? Flip the bottom and multiply. So then that's going to be 1/2 times 10 over 9, right? Which is what? 5/9. Talk to me, Hunter.
0.5 and 0.9.
Move this decimal point once. Move that decimal point once. Gets you 5/9. Yep. Either way. Okay. That's why you're at the crossroads there. Okay. So the sum there, or the fraction, if you will, is 5/9.
Nice.
Questions on that one? Now, on this type of problem, okay, you're going to ignore the 5, and you'll bring that back in the end. Okay? So for now, ignore the 5. Okay? Try this one. So this is 0.146 plus 0.000146 plus 0. Oops. Right? Right? Because the 146 is what's repeating. Yeah? Yeah? So,
Why'd you get rid of the 5 thing? Why would you keep
is the 5 repeating?
No.
No. So what I had said was get rid of it, bring it back in at the end. Yeah. You weren't listening at that point in time. You were talking to Matt. Okay. So what's my first term? 0.146. What's my R? Yeah. Yeah. So my sigma would be from 1 to infinity of 0.146 times 0.001 to the n minus 1 power. Does my R value fit in my range to find an infinite sum? Yep, that fits in my range to find an infinite sum. So this is over right, which is so what's that fraction? So that's 146 over 999. Okay? So the final fraction then is going to be that repeating decimal plus the 5. Right? Okay? I'm listening.
Do you want it to be an improper fraction or do you not care?
In these cases, I don't care. Okay?
so
Because you have to bring that 5 in plus the repeated decimal part. So my final answer here would be 5 and 146 over 999. Now, did you make it an improper?
No, but I was going
Okay. Well, because the 5 then
to.
would be, so that would be 4,995, right? Plus 146. So that's 1, carry the 1, 4, carry the 1, 1, carry the 1, 5. That one, right? Okay. Over 999. Yep. Handle? Go for it. Okay. So, ignoring the 10 for right now. Okay. So then this becomes 0.36 plus 0.0036 plus 0.00036 plus, and so on. Okay? So that gives me a G sub 1 of 0.36. That gives me an R value of 0.01. Okay. Which gives me then a sigma. Still sticking with N. 1 to infinity of 0.36 times 0.01 to the n minus 1 power. Yes? Okay. So that is a 0.01 is in our negative 1 to positive 1 range. Okay. Not equal to 0. So we can find the sum of that series. Yes. All of these repeating decimals will be within your range. Okay. So then that becomes 0.36 over 0.99, which is 36 over 99, which can be reduced. Both top and bottom can be divided by 9. So that gives me 4 ninths. Oh, 4 elevenths, excuse me, yes. I was immediately in my brain, I was like, wait a second. 4 ninths is 0.4 repeating. Okay? So 4 elevenths there. Okay? So then my total, or my total fraction would be, was this one 10? 10 plus 4 elevenths, which would be 10 and 4 elevenths if we wrote it in mixed up number form, or 114 over 11 in improper fraction form. Okay? For a particular pendulum, each swing is 90% of the distance of the previous swing. Okay? So, tough to see this on the interwebs, but okay. So a pendulum swings like this. Okay? So each time the pendulum swings, so it starts here, it swings out, then when it comes back, it only swings to 90% of its total distance. So what's going to end up happening with it is it's going to end up slowing itself down, until it basically stops, right? Okay? So that is an infinite series, okay, with it. Now, what might help you is to draw out a few of the first few swings. Okay? So let's do that. Let's draw out the first few swings. Okay? So it's in the first swing, it travels along an arc that is 20 inches long. Yes? Okay. Then it swings back. But what does it swing back to? What does it swing back to? How far does it travel on its way back? It does not travel 20 inches on its way back. 90%? So what's 90% of 20? 18? Then it swings back. Swings back to what? 16.2? Then it swings back. What do you get? 14.58. Okay. So if I'm finding the total distance, that's going to be 20 plus 18 plus 16.2 plus 14.58 plus on and on and on and on and on. Right? So what's my first term? 20. What's my R value? 0.9, right? Or 0.90 if we want 0.90. That's fine too. Okay. Yeah. All right. So the total distance then would be that infinite sum, correct? So this would be, if I wrote out this series in sigma notation, I need to find that sum, the sum of all of those distances. Well, first question you gotta ask, does it go to infinity? Yes. Second question you gotta ask, is your R value in that -1 to +1 range? Yes. So you can find it. So find me the sum of that, or the total distance that pendulum swings. This is in inches, yes. I get 200 inches. Yes? Okay. So this is that 12.4 A homework, and it is due Thursday. The same as you got yesterday.
There's no formative tomorrow.
And there's no formative tomorrow. Yep. Can I push pause first?